Welcome to this My Note series video. In this video, we are going to look at trigonometry questions, and we are going to see how we can tackle them, especially from a test or an examination setting. Now, this is the first video of 5. So let's see how we can approach this situation. So we are firstly going to look at grade 11 2018 November paper, and we are going to cover trig diagrams, reduction, trig identities, special angles, and general solution. So this is the diagram. When you are faced with these types of questions, what you need to do is that you need to firstly deal with the diagram before you can look at the questions, because by just working out and finding the unknowns from the diagram, you can actually answer a lot of questions, or in fact lay the foundations for the solutions which are to come in the questions asked on the question paper. So these are the questions. In total, you have 28 marks. What I want you to do is pause the video, try these questions, time yourself as well. So for 28 marks, maybe give yourself 30 minutes. Try these out, and then we can work through the solutions together. So when you are given a diagram like this, what you can note from the statement is that they told you that OT is 17. So the unknown here is actually X. So we are not going to focus on the point P yet, because we are not told anything about the length of OP. So using the Pythagoras theorem, we can actually solve for the unknown, which is X, by substituting what we know. And when you are finding the root of 64, you must always remember that you have to consider both possibilities. So it's plus or minus whenever you have an even root, like a square root. But it is also at this point that your diagram becomes crucial, because it gives you an indication of which solution is relevant for this problem. So because your point T is on the second quadrant, you can see this vertical red dotted line, that it's meant to show you that you are dealing with the X, which is negative. So therefore, you conclude that your X is negative 8. And it's very important that you choose the correct solution here, because the solutions that are to come afterwards are dependent on this solution. So whenever you are dealing with this step, you need to make sure that you have the right solution. Now, this is also a reminder of how we define the trig ratios on a trig diagram. So keep this in mind as we approach the subsequent questions. So the second question is asking us to find the value of tan theta. So if you look at your definition, tan is y over x. So this is your y, which is 15, and your x, which is minus 8. The question for 5.1.3 is to find cos 180 minus theta. Now in this situation, it's similar to what you were doing above, but firstly you need to reduce here. So 180 minus is on the second quadrant, and cos is negative there. and using your definition, which is x over r, you substitute what you know and you can simplify and end up with 15 over 8. Moving to the fourth question, you have sine squared theta. So when you have a squared, you need to look at the trig ratio and then square the whole thing. So sine theta would be 15 over 17, but because it's squared, then you square the whole thing, and that is how you will get 225 over 289. Now, the final sub question here is asking us to find the value of a. Now, there are many ways that you can approach these questions with. So what I've actually noted here is a technique we learned from analytical geometry. If you look at T, P, and O, they are all on the same straight line. So therefore, they are collinear points. And for collinear points, it means that the gradient of TP should equal to the gradient of OP. So what you can do is you can write your gradient formula and substitute, and you can see that you only have A as an unknown. We cross multiply and end up with a linear equation. You transpose minus 6A to the left hand side and minus 30 to the right hand side, and you divide by 8 on both sides to get A being 15 over 4. (5.2) You are asked to simplify without using a calculator. That instruction is trying to tell you that you need to show your workings. So you can't just come up with something without showing how you arrived to that particular solution. So when you are faced with these types of questions, you need to think about reduction, think about co-ratios, think about negative angles, and think about angles greater than 360 degrees. So 120 is on the second quadrant, so we write that as 180 minus. 210 is third quadrant, it's 180 plus. Tan 315 is fourth quadrant, so that's 360 minus. And 27 is already an angle on the first quadrant, as well as 63. And there's something that you also need to note about those two, that when you add 63 with 27, you get 90, and those two trig ratios are different. It's sine and cosine, so that means you are dealing with co-ratios. 540 is greater than 360, so you say 540 minus 360. So if you simplify here, sine is positive on the second quadrant, cos is negative on the third, tan is negative on the fourth. And when you say 540 minus 360, you get 180. Now with co-ratios, sine 63 could be written as 90 minus 27, and because you have a 90, it means your trig ratio must change. So that just shows you that sine 63 and cos 27 are actually the same thing. So instead of sine 63, we rewrite it as cos 27. And of course, what you note there is that negative and multiplied by negative should be a positive. So even though I showed it there, but it's supposed to be not there at this point. So these two negatives for minus root 3 and minus 1. But it's fine because it works out in this situation. So you just substitute your special angles: sine 60, cos 30, tan 45, cos 180. Those are all special angles, even though 180 is not part of the typical 3. So this will divide that. So cos 27 will divide cos 27, and you end up with minus 3 over 4. Now we come to a trig identity question, and for this question you choose the complicated side. In this case it's the left hand side, and if you look at your solution, which is tan theta, it's just one trig ratio, one term. So you need to combine these two fractions, and in order to do that you need to find the lowest common denominator. And when you do that, you have to multiply by a special 1, which will yield the lowest common denominator in both scenarios. And once you do that, you have the same denominator, which means you can take one denominator and add or subtract the numerator. And if you look at your numerator, you have a small problem there. You have different trig ratios. However, you can use your square identity to change that cos to be a sine, and that is exactly what we do there. And if you simplify, you end up with sine squared theta plus sine theta on the numerator, and you can take out the common factor and you can divide what is the same, and you end up with sine theta over cos theta, which is tan theta, which is equal to your right hand side. Then finally, we look at a general solution question. So in this case, and so when you are dealing with general solution, you always try to have one trig ratio. And immediately when you look at your right hand side, you can see that you have tan. And in trigonometry, when we see tan, we change it into sine over cos. So when we do that, we now have a fraction on the right hand side, and to get rid of that fraction, we can multiply by cos x on both sides. And this is the situation that we have. Now it is at this point that you need to be careful. It's very easy to be tempted to divide on both sides by sine x. But as a rule in mathematics, we do not divide by something that we do not know. And the reason for that is there is a possibility that that thing is 0. And if we divide by 0, you know that you have undefined solution, an undefined solution. So what you need to do is to transpose what is on the right hand side to the left hand side and take out the common factor. You end up with sine x times 3 cos x minus 2. And so that means sine x is equal to 0, or cos x is equal to 2 over 3. Now starting with sine x equal to 0, so if you say shift sine 0, you get a reference angle of 0. Now 0 is kind of an interesting angle because it is a boundary angle or a quadrant divider. So it does not belong in any quadrant. It defines quadrants. So therefore you are dealing with a special scenario. Your solution will be x equal to 0 degrees plus. Now if you think whenever you get those quadrant dividers, so that is 0, 90, 180, what you need to think of is your graph. So in this case we are talking about the sine graph. So if you draw a sine graph, it starts at 0, which is your reference angle. and you have to count how many degrees it takes for it to get back to 0. You will recognize that it is 0 at 180 degrees, so it takes 180 degrees, so that is your period of getting 0. Now the second case, which is cos x equals to 2 over 3, is a more straightforward case. So you have to check where is cos positive. It's first and fourth quadrants. So on the first, it's x equals to your reference angle plus k times the period for cos is 360. Don't forget to write k an element of integers, or you can have your solution on the fourth quadrant as well. Thank you for watching. I'm hoping that you learned something. I'm available on all those 3 platforms, and you can watch the videos in the platform you find most comfortable and familiar. Thank you.